All right, guys, I think we finished up with this problem here yesterday. I can't remember if we did this problem or not, or we stopped on this one. Did we do this one here? Okay, I mean, I can go back over it because, again, we're just distributing. We're multiplying through. So 15i minus negative 1 would be negative 15i. 15i times 2i is going to be plus 30i squared is what we have. Now, when I do these here, because I squared is the same as negative 1, yes? So really, all it's going to do is change the sign for 30 from positive to negative, yes? So when I look at these, I'll cross that out and then change the sign from positive to negative, because that's all it's going to do, which will tell us that this is negative 30 minus 15i. Questions on this here? Yes. I think this is 3.41.
Where? I've been looking. Oh, there's that. Oh, we already did this.
Yeah.
That's why I was so confused.
So this is where we stopped. Now, when we do this here, it's going to be the same as when we multiply two binomials, like when we did something like x plus 2 times x minus 4. A problem like this here where we use the distributive property to multiply out. So what we can do first is multiply both sides, or distribute our 9. So we do 9 times negative 4. And 9 times negative 4 is negative 36. Then we do 9 times 7i, which is going to be plus 63i. Then we can do the next part, which is multiplying by negative 2i. Well, negative 2i times negative 4i is going to be plus 8i. And negative 2i times 7i is going to be negative 14i squared. Questions on this so far? Now, we know I squared is what? Negative 1, yes? That's going to be the one that shows up the most often. So kind of remembering that I squared is negative 1 is somewhat helpful. Now, for the most part, I squared, since it's negative 1, it's just going to do what? It's going to change the 14 from being negative to positive. So one way we can look at it is I can mark it out and change the sign from negative to positive, because really that's all it's going to do. The other way to look at this is to say, well, we can combine these two middle terms, which would give us 71i, which would be negative 14 times negative 1. Yes. 71i. Negative 36 plus 14 is? And we get this here. Now, again, because the way I wrote it at the start was we could cross that out and make that positive, because that's what we did, isn't it? Because with the negative 1, it made it positive. You can write it either way. Both work the same. So this really just tells us that I have negative 36 plus 14. We can get to the same answer. Because I'll cross the I squared out, change the sign, and work from there, because I squared is just negative 1. And with any of these multiplication, no matter how many that we do, if we change I squared to -1 each time it shows up, it'll simplify it out. That way, when we get to, say, I cubed, we don't have to worry about it. Because if I change it at I squared to -1, the likelihood that we'll get I cubed or higher power is lower. But any way that we do this does work. Questions on this here? Yeah. Yeah, that's all of it. Questions on this here? 4 minus 12i times 11 plus 8i. Now we can type this into the calculator. I ignore everything above that line I just typed in. That was from the previous class. And it'll give us the answer. Now, for this here, so we could still have it in real numbers, it'll still give us the answer. Having it in A plus BI form or as real numbers doesn't really affect these with addition, subtraction, multiplication, and what we'll look at today, division. What it's helpful, or the reason we need it in that form, is if we're trying to take the square root of a negative number. Then we need it in A plus BI form. But the calculator will do this for us. Questions on this here? And for the most part, the way that we multiply, add and subtract, is essentially the exact same as if it was a variable. The only difference is if it gets a power greater than 1, we have to simplify it back to being either I, -1, -I, or 1. Other than that, it's not too different. Questions on any of this here? Okay. Other side. This is the assignment for this here. So 6 through 12, 19 through 23, 32, 34, and 44 through 50 even. So we'll look at the other sheet. Or you're going to copy. "32, 34, 44 through 50 even." So next page. Right there. Yep. So, yep. I realized after I ran all the copies that instead of doing one-sided to two-sided, I did two-sided to two-sided. So the back side that I reuse sheets of paper if I can. Because if you notice the date on both of those is from several years ago. So neither one of those is still here. They've already graduated. Now, the complex conjugate theorem. Complex conjugate. So if, well, this is really dealing with solutions, but it also works with this here. A plus bi. All right, guys, so if a polynomial function with real coefficients has a plus bi as a solution, or a plus bi, it also has its complex conjugate. And the complex conjugate for a plus bi is a minus bi. And we'll get into, especially when we have solutions, if a plus bi is a solution, a minus bi is a solution. And what we call these two are complex conjugates. So a plus bi's conjugate is a minus bi. Questions on this so far? What is the complex conjugate of 7 minus I? Seven plus in front of I. Now there's something interesting that happens with these two here. I'm going to multiply these together and see what we get.
Wait, is this like a part of the answer?
Yeah, and it will be a part of the homework. So we can distribute like we did on the last one. 7 times 7 is 49. 7 times I is going to be plus 7i. Then we can do negative I times 7 is negative 7i. And negative I times I is negative I squared. Well, we still have the 49. What's 7i minus 7i? 0. Okay, those are gone. Minus, well, I squared is negative 1, yes? And what's 49 minus negative 1? What happened to all the imaginary terms? They disappeared. They canceled out. They simplified out. And that's what's helpful, or what's interesting with these complex conjugates. And that's also why if we have one of them, if a complex number comes up as an answer, its complex conjugate is also. Because again, these imaginary terms, these kind of solutions are what we're going to get when the graph does not cross the x-axis. And if we think back to those equations where it didn't cross the x-axis, did we have any I terms in the equation to begin with? Well, no. So that's why we need these kind of complex conjugates, because when they work together, all the imaginary parts are gone. They cancel each other out. So if we have one, we have to have the other. If you think back to all the square root ones we had, where we came up with the square root of 3, but we had the positive and negative, yes? Same thing here. If a plus the square root of b is a solution, then a minus the square root of b is a solution as well. We need both. Because radicals, irrational solutions will always come in pairs. Complex numbers will always come in pairs. All right, let's look at the next one. What's the complex conjugate of 5 minus 5i? Negative 5 plus 5i. Because we're only changing the sign in front of the term with I. think this works out to be 50 as well. Bless you. Yeah, we can type it in just like we do here. You know what's interesting with this here? What was the difference of perfect squares formula? A squared minus A minus B times A plus B, wasn't it? Two things with the signs different. So really, what are we looking at? Negative 5 squared minus 5i squared. But we could plug it into the calculator and do that. Or if we distribute out, negative 5 times negative 5 is 25, negative 5 squared. Negative 5 times 5i is going to be negative 25i. Negative 5i times negative 5 is plus 25i. And lastly, negative 5i times 5i is negative 25i squared. Well, the I squared is going to make this what? Positive, isn't it? These in the middle cancel. 25 plus 25 is 50. Questions on any of this here? So we understand how multiplying them together gives us a single number without I? Yes? So we'll just look at these here. So what's the complex conjugate of negative 2 plus 4i? How about 3 minus 6i? Mm-hmm. And minus 2i would be? And lastly, negative 4 minus 8i? Mm-hmm. I think we feel comfortable with these here, yes?
So,
How about the complex conjugate of negative 9i? What would the complex conjugate of negative 9i be? It'd be 9i, because we're changing the sign in front of I, yes? What's the complex conjugate of 4? That's it.
I know.
What's the complex conjugate of negative 9i? What's the complex conjugate of 4?
Oh, there's no I. Okay. Gotcha.
Yeah, I just added those.
I thought we were doing this thing.
So the next thing is this here. Now the issue we have with this is that we can't have I in the bottom of a fraction. We can't have I in the bottom of the fraction. So what we need to do is we need to simplify it. Yep. And the way that we can simplify this is with these complex conjugates. Because the complex conjugate of the denominator, the complex conjugate of the 1 minus 2i, when multiplied with it, will give us a number. It'll cancel out all of the I terms. So what I can multiply the denominator with is 1 plus 2i, because 1 plus 2i and 1 minus 2i will simplify all the I terms out. I'm also going to multiply the numerator with 1 plus 2i. And the reason we can do this is something very simple. What is 1 plus 2i divided by 1 plus 2i? So what am I essentially multiplying this fraction by? 1. I'm not changing anything. I'm just multiplying it by 1. It's a fancy version of 1, but it's still 1. So it's not changing what we have, it's just changing how it looks. I'm not changing the value, just changing how it looks. So we don't have I in the bottom of the fraction. Now we multiply this. We're multiplying these two here on bottom together. So we'll have 1 times 1, which is 1. 1 times 2i is plus 2i. Then we'll have negative 2i times 1, which is negative 2i. And lastly, we'll have negative 2i times 2i. Negative, that is 2 times 2, 4. You're good. Now the I squared is going to make this 4 positive. And the 2i minus 2i is going to become 0, leaving us with what? 1 plus 4, which is 5. Now we're going to do the same thing with the numerators. So we'll have 4 times 1, which is 4. 4 times 2i is plus 8i. 3i times 1 is going to be plus 3i. And 3i times 2i is going to be plus 6i squared. Well, what do we know about I squared? It's going to change that sign from positive to negative. So what we could do is cross the I squared out and change it from positive to negative. And I find this a little bit simpler than rewriting that back out as plus 6 times negative 1, which is going to make it negative 6. Now we can combine like terms. 4 minus 6 is negative 2. 8i plus 3i is going to be plus 11i. Now most would not consider this in standard form because they want us to split that fraction. And splitting a fraction is actually not too bad. Because if we add 2 fractions together, the denominators have to be the, so if I split them, it'd be negative 2 over 5 plus over 5i. The denominators would be the same, we just put the numerators on top of each fraction. So, I would, but we can, why don't we try using the calculator for the next one? We ready for the next one? One minus 4i over 2 plus 3i. So we can pull the calculator up. I'm going to clear all that out. So alpha y equals enter. So 1 minus 4i over 2 plus 3i. 1 minus 4i over plus 3i, yes? Alpha y equals enter. Yep. And unfortunately, this calculator here is a little bit nicer. It's the 84 plus CE. We're working on trying to get more of those because we have about 9 of them at the moment. They're about $20 more than the ones that y'all have, but we're trying to work to get a full set so that y'all can use them. It is still possible to do this. It just takes a few more steps. Instead of writing it as a fraction, we're going to write it as a division problem. Yep. Okay. Just wait. So, before we do the next step, because we're not quite finished with this here, has everybody at least gotten to this point here? But the way that we want the answer is not in decimal form. We want it as a what? A? How can we change it to a fraction? Math. Enter. Enter. So it'll do it, we just can't type it in math print, where it actually puts it as a fraction to begin with. We have to set it up as the two being divided, get the decimal version of the answer, and then convert that to a fraction. Math, enter, enter. Negative 10/13 minus 11/13. That's it. Questions on this here? Try doing this one here. Yep, it gave it to you as a fraction already. What did it give you? Because if we wanted to do this by hand, what we would do is we'd multiply this by negative 4i over negative 4i. Well, the denominator, 4 times negative 4 is negative 16, and then we would have I squared. Well, the I squared is going to turn this from negative 16 to positive 16. The numerator, negative 4i times 2 is negative 8i. Negative 4i times 5 is going to be plus 20i squared. Well, the I squared is going to turn the 20 from negative to positive, because it should have been negative 20 to begin with. Because negative 4i times 5 is going to be negative 20. So we have 20 minus 8i over 16, which would be 20 over 16 minus 8 over 16i. 20 over 16 would be, well, I was just simplifying down.
Okay. I was like, whoa.
5/4 minus 1/2 I. So Austin, when you typed it in, did you make sure to have parentheses around the 4i? Yeah. Okay. The one thing about the graphing calculator is that it will write over the top of it. So if you put the division but forgot to put a parentheses and went back, it'll insert, so it'll write over the top of what you have printed. So if you'd gone through, typed that in, but forgot to put the parenthesis around the front of the 4, and went back in front of it and put parentheses, there's a good chance it deleted that division to put the parenthesis in its place. So if you've ever hit the insert key on the keyboard, if y'all know what that is, where and you don't, and then you start trying to type in a certain spot and it just erases everything. These calculators are set essentially in that form. It'll insert wherever you're at. But questions on this here? But that's it. Because the rest of this is the exact same thing. I'll tell you right now, the homework sheets are the same way as, yep, I accidentally printed two-sided to two-sided instead of one-sided to two-sided. So the back sheets of these don't do them